Morning, guys. This is AP Chemistry, topic 9.5, free energy and equilibrium. Hashtag not sponsored by Nintendo or the Super Mario Brothers movie or anything like that. So your objective is to be able to explain whether a process is thermodynamically favored using relationships between K, delta G standard, and also T. So the essential knowledge is, keep an eye on this, please. So thermodynamically favored, that means your Gibbs free energy standard is, or standard Gibbs free energy is less than 0, and that means products are favored at equilibrium, so K is going to be greater than 1. There are a couple of other equations you're going to have to know, so make sure you guys know that. So in Unit 7, we saw that K values tell us about the position of equilibrium. If it's a K value that is larger than 1, products are favored at equilibrium. So this should be a refresher for you. If a K value is less than 1, that means that reactants are favored. We can apply the same idea to Gibbs free energy. So reactions with negative values for Gibbs free energy tell us that it's considered thermodynamically favorable. That means the products are favored. If a K is greater than 1, that means we are indicating thermodynamic favorability right there. If we're at equilibrium, the Gibbs free energy is 0, the K is equal to 1, and you have an equal preference for reactants and products. If it's thermodynamically unfavorable, that means Gibbs free energy is positive, K is less than 1, so your reactants are considered favored. So there are a couple of equations we can use. So your K, your equilibrium constant, is equal to the E of the negative Gibbs free energy divided by RT. Or Gibbs free energy equals negative RT natural log of K. So there are different types of R constants to use. It depends on your units. So you may remember one from gases 0.08206. This one is 8.314 joules per mole Kelvin. So your K needs to be in Kelvin. Your Gibbs free energy needs to be in joules per mole, and K is your constant and is unitless. So careful, this K is not the Kelvin or something. You might think it might be the same as this one, but that's not the case. So don't try to avoid thinking that. If your Gibbs free energy is near 0, your K will be near 1. As it becomes more negative, the K will increase, and the reaction will favor the products. So again, just kind of remember this relationship for this particular unit, or I guess topic. Given the equilibrium constant at 298 Kelvin for the following reaction, determine the value of standard delta G. So we have a K value, we have a temperature. Can't really do too much. So we got, actually we can do a lot. So we have delta G standard equals negative RT natural log of K. So negative 8.314 joules per mole times Kelvin times by temperature 298 Kelvin, natural log of 1.40 times 10 to the 6th. I do my math, I'll end up with negative 35,100 joules per mole, or negative 35.1 kilojoules per mole. Calculate the value of delta G standard at 298 Kelvin. We have an equilibrium constant here. So luckily for us, it's pretty much the same thing. So we have our temperature. We have some K. So delta G is my unknown. So negative 8.314 joules per mole Kelvin, 298 Kelvin, natural log of 5.5 times 10 to the negative 3. So the answer is going to be 13 kilojoules. All right. You have any questions, please let me know. Thanks. Hit the like and subscribe, blah, 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 etc., etc.